Okay, like I said, this could be possibly the last chapter that we do this marking period. I don't know. It depends on how fast we go, if you understand it or not. And we may start another chapter. I don't know if we'll have time to get 2 full chapters in. I kind of doubt it, because I think that last week we're going to have to review for finals anyway, right? And I'll probably do what I did for the midterms. Remember, I put them up on YouTube. So I may not take as many class periods as other teachers do, because I'll probably put the old tests that we've taken, we'll probably put them up on YouTube. So start looking for them, and not this week, don't look for them, but maybe next week start looking for them, and you can start reviewing even next week. All right, chapter 11 is about area. I don't know if we've talked about area at all this year. Have we talked about it at all? Yeah, we did. Did we do area of a circle? I don't think we did that, did we? No, I don't think we... Yeah, we did circumference of a circle, right. So we did perimeter. We've talked about the distance around something, but we haven't really talked about the area of something. Well, what they do is they start off... I'll tell you what. Let's start off with this. That's a rectangle right there. And basically, what are we finding when we're finding the area of something? What we're doing is we're taking this rectangle. Now, I don't know if I'm doing this... exact or not. I'm not going to take the time to make sure it's exact, but we'll just kind of watch. If I did this, did that, and let's say about right there, and maybe not. Let's do this. Sorry, I probably should have had this prepared. I just thought of doing this. They don't start off like this in the book. They start off with a parallelogram. I mean, this is a parallelogram, but... And what if I did this? What I'm trying to do is I'm trying to make them into squares as much as possible. We'll see if they are or not. That's pretty close. That's not too bad. Use your imagination. Pretend they're all perfect squares. Is that all right? And let's see. So let's count how many across I have. I got 1, 2, 3, 4, 5, 6, 7, 8. I got 8 across. Would you agree? Now, you've done this many, many times when you're a little kid. Instead of counting every single square, what do they tell you to do? Count across and then count what? Up and down. 1, 2, 3, 4. Up and down. So what can we do with those to find out how many squares are in this whole entire rectangle? Just multiply those two numbers together, right? So 8 times 4. So we'll call this the length. We'll call this the width. And so what we're doing when we're finding the area, we're finding how many of these little squares are in that whole entire figure. That's what we're doing when we're finding the area of something, because we actually measure it in square units. And you've seen this before, haven't you? You've done a lot of this probably in middle school. I don't know if you did too much of this in algebra. Probably not. But I know you did this in middle school math, didn't you? Yes? You remember doing this? Or even elementary, probably, you did this stuff. So what are you finding? You're finding... to find the area, you're finding how many of these squares, remember, pretend they're perfect squares, okay? How many perfect squares are in this particular figure? I have a rectangle right here, so we want to figure out how many. So we go 8 times 4, because we go across and down, or we could say what? The area of a rectangle is equal to the what? Length times the width. That's how you hear it most of the time. What I'm going to do, let's change this. Instead of length times width, let's call it something else. And it's something that we're familiar with because we've talked about this before. Let's call this thing the base. Okay, and let's call this up and down part the height. Now, there's got to be something true about the base and the height. This is very important. And we've discussed this earlier. Remember we talked about altitude and things like that? We've talked about this kind of thing before. So if I have a base and a height, what must be true about the base? Because the bottom would be considered the base as well, and this would be the height. What must be true about the base and the height? They must be what? Perpendicular. That's right. So the base and height must be perpendicular. You with me on this? So if I started off with a rectangle, oh yeah, the base and the height, they are perpendicular. So instead of calling it length times width, it doesn't mean it's wrong. I just want to change our terminology a little bit. When you're a kid, you always learn length times width. But what I want to start saying now, instead of length times width, what do you think we're going to say? Base times height. Okay, so we'll call it base times height. I mean, it's really the same thing as far as our numbers and all that kind of stuff, but our terminology is a little bit different. Because if I just say length and width, it's not really in the definition of length and width to mean that they're perpendicular, but in base and height it is. So I think it's important to say base times height. Does that make any sense at all? That's not too hard to understand, is it? All right, so, and we've talked about that. We've talked about the base and the height being perpendicular to each other and all that good stuff. So that's what we're finding. And we can find the area of all kinds of stuff. We can find the area of triangles, of different parallelograms, of trapezoids, of circles, of all kinds of different stuff, of semicircles, of different parts of a circle. We could find all kinds of different areas, and that's what we're going to do basically this whole entire chapter, is learn how to find the areas of all these different types of shapes. All right, we've learned a lot of these shapes already. Probably, my guess is, every single shape that we're going to do the area on, we've already learned something about it at some point this year. Okay, so you shouldn't be, I'm sorry, you should be familiar with a lot of the shapes we're going to talk about. We just haven't talked about finding the area of those things. All right, does that make sense on what we're trying to do? We're trying to find the area, how many squares fit inside of that particular figure right there. Everybody good? All right, so now that's a rectangle, base times height. But any parallelogram, remember this thing? We had a whole entire chapter, didn't we? On this kind of thing right here. Any parallelogram, the area is exactly the same. So the area of any parallelogram is the base times the height. I'll just put BH next to each other. All right. So if you take a look at this, which one is the base and which one is the height? Well, it doesn't matter which one you call the base, as long as the height is what to the base? Perpendicular. Okay. So if I call this the base, is that thing right there the height? Why not? Because it's not perpendicular to this. Exactly right. Does that make sense? So what we do, where is the base? The base could be all kinds of places. It could be from here, where? Not straight down, don't say that. We've talked about this a lot this year. It's what? Perpendicular to the base. So this pink line right here would be considered the height of that, I keep saying, thinking trapezoid in my head. Parallelogram, thank you. For some reason the word trapezoid was in my head. This parallelogram. So it's still the base. Now look, the base is the entire, it's this entire length right there. Just because I took the height to here doesn't mean the base is only that part. Okay, the base is that whole entire length. Now on a parallelogram, I'm not going to go through everything we've learned on a parallelogram, but what was one of the main things we learned about a parallelogram? The opposite sides. What's true about the lengths of the opposite sides? They're equal to each other. Okay, so if they gave me this length right here, this down here on the bottom would be exactly the same. Would you agree? Because the opposite sides are equal to each other. All right. Sometimes they give the height like right here. Could that still be the height? Sure it could. Okay, because it goes from one base perpendicular to the other one. You see it? We good? Now look, they probably won't do this often, but they could. Oops. Oh, what am I doing? Sorry. Gotta get used to this again. Of course, I did use this over the break. All right. What if we started here, and we called this the base? Tell you what. Let's get rid of this. Let's get rid of this. Start from scratch again. All right. What if this was called the base right here? Then what would I have to do to find the height? Let's do a different color. Do I just go straight across? No, I don't just go straight across. If this slanted side right here was the base, I don't just go straight across to find the height, do I? What do? I've got to go perpendicular. So I don't know what looks perpendicular to you. About right in there somewhere. It's pretty close. Okay. So look, if that was perpendicular, if this is considered my base, and this line right here was perpendicular to this one, then this would be my what? That would be my height. Now a lot of times they don't draw them, you know, from somewhere in the middle. So a lot of times they'll take it from a corner, but they don't have to. Right? That's still, oops, that's still the height right there, as long as that's perpendicular. Does that make sense? We good with that? All right. That's pretty easy stuff. Let's do a little example, then we'll move on. Okay, here's an example. And it's a parallelogram. I think they tell you, yeah, they do. They tell you it's a parallelogram. And they give you these things right here. They're asking for two things now. Now, I discussed this a little bit, just briefly earlier. We've learned how to find the perimeter of stuff. Okay, we have found that kind of stuff before. The perimeter just means the distance around it, but we also want to find the area. So we're finding both of these things right here. Okay, the perimeter and the area. Let's just do the perimeter first. Now remember, it is a parallelogram. They told us in the problem that this was a parallelogram. They labeled it ABCD, and they say find the perimeter of parallelogram ABCD. So since we know it's a parallelogram, if this side is 10, tell me something about this side over here. That's also 10. If this side is 4, talk to me. That's 4. So the perimeter is pretty easy. What do we do to find the perimeter of this thing? Just add them all up. 10 plus 10 is 20. 4 plus 4 is 8. What is that? 28. So that was pretty easy, wasn't it? Find the perimeter. That was nothing new. We've talked about that before. Okay, the area is the thing that's new. Remember, the area is the base times the height. So it just depends on which one you want to call the base and the height. What about 10 and 4? Would 10 and 4 be my base and my height? No, because 10 and 4 are not what to each other? Perpendicular. So what are you trying to do then? If you get a little confused, you try to look to see the two lengths that are perpendicular to each other. So look at this. Which ones are perpendicular? The 5 and the what? And the 10. That's right. So it's the 5 and the 10 that are perpendicular to each other. So it really doesn't matter which one you call the base or the height. We'll call 10 the base. We'll call this one right here, this 5, we'll call that the height. So you just go 10 times 5 is 50, and you're done. That's it. Oh, by the way, I forgot. Remember we broke that into little squares? Let's say this was in inches, all right, and this was 4 inches, right? What we would do, because we're going 10 inches times 5 inches, what's inches times inches, right? Because that's 10 inches times 5 inches. Inches times inches is inches squared, okay? Or sometimes you'll see it written like this, square inches. It doesn't really matter. I'm perfectly fine with that. If you go buy carpet or something for your house, they'll measure it usually in square feet. They'll say, you know, this is measure, it's $3 per square foot or something like that. That's what they're talking about. They're talking about the area of the carpet, so square inches. Now, as far as this class, I probably won't mark off if you don't put this on here. There are some teachers that would mark that problem wrong. Even though you had the 50, they might mark it wrong if you don't put inches squared. Okay, I probably won't do that. Wow, excuse me. But I used to teach physics, and if they didn't put the units, the correct units in my physics class, excuse me, I did mark off for that. But in here I probably won't. All right, let's do another one. Let's do that. Let's put that rectangle up here again. And let's see what we can do here. Watch this. I think I might have even talked about this a little bit before. That's a rectangle. And what if I did this? What if I cut it, put a diagonal from there to there? What have I done to that rectangle? I split it into two what? Two congruent triangles, didn't I? Okay. Now there's a little, I don't even know if it's a theorem or not. I think it is. Yeah, it says if two figures are congruent, this is a theorem, or a postulate actually, it can't be proven, but it says if two figures are congruent, then they have the same area. So we already talked about this triangle and this triangle being congruent to each other, and if they are congruent to each other, they have the same area. So if you think of this, remember what was the, this was the base, and this was the height. This was a rectangle, so that's a right angle. What have I formed right here? What is this thing? Just right here. I formed two of them. Two triangles, okay? We just talked about that. The two triangles are being congruent. But if I just want to talk about this one triangle and I want to find the area of that triangle, that's right. It's exactly half of the whole entire rectangle, isn't it? Well, what was the rectangle? The rectangle was base times height. What is this triangle? It's what? It's half of that rectangle. And there you go. That's the area of a triangle. That's how you find it. The area of a triangle is base times height divided by 2. Or you could write 1/2 the base times the height. I kind of like this one a little bit better, but they both mean exactly the same thing, don't they? All right. So we okay with that? That's how you find the area of a triangle. So you've got two formulas you got to memorize. The area of a parallelogram, okay? Now, why don't I give two separate equations for area of a parallelogram and area of a rectangle? Because a rectangle is what? It's a parallelogram. That's right. So if I just say here's the area of a parallelogram, it's going to be the same for a rectangle. So the area of a parallelogram is base times the height. The area of a triangle is just half of that. And if you forget, just kind of picture that rectangle, drawing a diagonal, cutting it in half. So the area of the triangle is 1/2 the base times the height. That's pretty easy, isn't it? Let's do an example with that. Actually, I lied. Before we do an example with that, let's talk about a couple different styles of triangles. One, we already showed, but I'm going to put all three of them up here. Is it raining? It sounds like that truck went by. It's going through the rain. Okay, this is a right triangle. This is the easiest one, okay, because that's the base and that's the height. How do I know they're base and height to each other? Because they're perpendicular, that's right. If it's a right triangle, I know this side is perpendicular to this side right here. So if that's my base, this one has to be my height. Would you agree? So that's the easiest one. But we have other types of triangles, don't we? We have triangle like this. I wouldn't say it's isosceles. I don't know. It could be. But I didn't try to draw it isosceles. But as far as our angles are concerned, what type of triangle does this look like? What is it? Not according to the angles. According to the sides, it could be scaling. What is it? It's acute. Right. It's an acute triangle. At least that's how I tried to draw it. So let's say I called this the base right there. What would be the height? Would the shorter one be the height? Would the longer one be the height? It's perpendicular. Where would I start, though, on a triangle? Start from the very top. Okay, and then I draw it, what? Not straight down. I know you're tempted to say that. Perpendicular. That's right. Perpendicular to that. So this pink one right here would be the height. Make sense? Now, what is the base? The base doesn't just come to here, does it? The base is that whole entire length from here to here. That's the base. Make sense? All right, so we had a right triangle. We have an acute triangle. What other kind of triangle do you think we're going to talk about here? Obtuse, right. So let's draw an obtuse triangle. Let me get my lines thing here. So let's draw it like this. Let's draw it like this. Now this is the weirdest one out of the three. Let's change my color now. Let's go with that same pink. All right. Let's say I called this the base right here. Again, it all depends on which one you call the base. If I call this one the base, which one would be the height? Is it the one from the top down to the base like that? Okay, why is this one not the height? It's not well, it's not perpendicular, first of all, right? That's why it's not the height, okay, because it's not perpendicular to the base. All right, Nate, you said it. What are you going to do? Okay, so let's do that. He said let's extend the base out, and you can extend it as far as you want, but where is the oops, let me get back to this color. Okay, where is the height now? It's from the top of the triangle, where? Perpendicular to the base. Now I had to extend that base out, didn't I? So this little part from here to here is not really part of the base that I'm going to use as my numbers are concerned. Okay, so if I gave you the base as 10, I'm not going to extend it out and say, oh, this from here to here is the base. No, this is still the base of the triangle, because this little bit right here isn't really part of my triangle, is it? Do you see that? From here, you see it? From this point right here to this point right here is the base of the triangle. This would be the height of the triangle. Travis?
Is the, when you cut that triangle in half, is that also the height?
If I cut it in half, what do you mean? Like from here? From here?
Down.
To like here?
To your left. Right in that corner. No, to your right.
This one?
Yes.
That angle?
If you cut it in half, like perpendicular to the hypotenuse, would that be the height also?
Well, perpendicular to the hypotenuse would be this line right here. So on this little triangle, this would be if the
He's talking about the big triangle.
no, this part right here, we're not going to include at all. That it's just an extension of my triangle, okay? It's just I shouldn't have put it as a solid line right there. In fact, I probably should have put it as a different color. Let's I probably should have done this. Actually, let's change. I don't even want that color. Let's change to this color. So I should have probably done it like this. See that yellow? That yellow is not part of my triangle. All I did was take this side, extend it out. So this is my height, but this is the base. Okay, see right? That's why I did this thing right here, because I knew there would be a little bit of confusion on that. That's still part of my triangle, okay? This isn't really my triangle, is it? This is just an imaginary line drawn an extension of this side right here, of this base. So this really is not part of my triangle. So this part right here has nothing to do, as far as the length of this side, it's got nothing to do with the area of this triangle. Does that make sense? I hope that answers your question. Okay, so there you go. Do we have time? Yeah, we got time to do an example. Let's do an example. All right, here's an example. This one's a little bit trickier than just sticking in numbers and just throwing them into a formula. What it says is this. It says the height of the triangle is 5 centimeters more than its base. All right, so which one would be my height? This yellow one, right? Because it's perpendicular to this side right here. So this bottom right here would be the base, and this yellowish one right here would be the height. But it says the height, what does it say again? The height is 5 centimeters more than its base. Do I just pick a number for the base and just add 5 to it to get that? Yeah, we'll call the base, well, instead of calling it x, let's call the base b. All right? You could call it x if you wanted to. And then the height is what? It's 5 more than the base. So what would I call the base or the height? b plus 5. Good. Does that make sense? All right, so it says, and it tells you the area. So this time, they don't ask for the area, they tell you the area. It's 52 square centimeters, so centimeters squared. And you want to find the base and the height of this thing. All right, so how in the world are we going to do that? Well, let's use our formula. So Nico, what is it? Tell you what, let's write our formula down first. Is that all right? I don't know, do you like the half or you like the over 2 better? Over 2? Let's go over 2 then. All right, so what am I going to put in? Tell me, Nico. Well, let's put the 52 in here first, right? Because area is 52. You see what I'm doing? I just plugged in a 52 for the area equals b, which is what? Just b, right? Times the height. What's the height? b plus 5 over 2, right? And now what do we have to do? Gotta do some math. Solve for b. This one's gonna the math is a little more confusing because you're gonna get a quadratic out of it. But we talked about how to use the quadratic formula, didn't we? We even talked about how to factor a little bit. Next year, you're definitely going to be expected, without a doubt, to do this. This year, I kind of make it a little easier for you, and I probably won't give you something like this on a test with the quadratic formula. But anyway, you should, at this point, know a little bit how to do that. So I tell you what, the first thing I'm going to do is get rid of this 2. How can I get rid of that 2? Multiply both sides by 2, correct? So what's that going to be? You can do that in your head. 104 equals, what's this going to be? It's going to be b squared, right? Plus what? 5b, all right? Just distribute it here. Now look, if you remember from algebra, it's a lot easier, it's a lot nicer. This is a quadratic equation. So it's nicer if I put everything on the same side with the b's and then set it equal to 0. So that means I'm going to take this 104, throw it to the other side, which would make it what? Minus 104 equals what? 0. All right. Now this actually does factor. I'll just show you. What are my numbers? I can't read. 13 and 8. Now that didn't pop into my head. 13 times 8. Is it to you? No, but it is. It's 13 and then negative 8. Because if I multiplied 13 and 8 together, I get 104, negative 104. And if I add them together, I get a positive 5. Do you remember doing that in Algebra 1, factoring? All right, so that's why they taught it. What's that? Well, it's kind of backwards FOIL. Okay, I mean, to get to this, you would FOIL. But to get from here to here, you factor. Do you remember that from Algebra 1? You did factoring, didn't you? Did a little bit of it. If not, you could always take this and put it into the what? The quadratic formula. X equals what? Negative b plus or minus square root b squared minus 4ac over 2a. You could do all that stuff if you wanted to, and you could get an answer. That's fine. But I like to do this. So what do you do on this one? You set them both equal to 0. So if I take b plus 13 equals 0, then I'm going to take b minus 8 equals 0. Solve for b. b is negative 13. b is 8. But think about this. This is not just an algebra class. If this was Algebra 2, you would circle both of those answers, and they would be both of your solutions. But this is not algebra. We're actually solving for a length of a side. Can a length of a side be equal to negative 13? No. So we don't even include this at all. We just throw that one away in geometry. Okay, because when we're finding the length of something, it's not going to be negative, so we just toss that. So what is b? It's 8. And what is b plus 5? What is the height? Just 8 plus 5, which is 13. There you go. So there's your base, or there's your base right there, which is 8, and there's your height, which is 5 more than the base, which is 13. It's about as hard as it gets right there. We good with that? Yeah, that's not so bad. All right, let me give you some problems to do. All right, so what did I say it was? Page is what? 767, 768, 10 to 22. All right, there it is. Remember, do all your homework, okay? You can't afford, some of you guys cannot afford to miss any homeworks, okay? And if you want to keep, some of you guys to keep your A, you must do every single homework, okay? To do well in the test, do your homework, because doing your homework and doing it properly, not just doing it just to turn it in and get a 5, but doing it properly helps you do better on the quizzes and on the tests. So make sure that you do that. Stay in your seats till the bell rings, please.